Welcome back to Engineering Inebriated. Today we're going to talk about an intramolecular aldol condensation that was carried out as shown. This is a practice problem for the University of Michigan ORGO 2 Exam 2. So here's the question. What we have is the chemical formula for the structure that is reacted with a strong base, KOH, and that this is the final product. So just from this alone, we're going to know how to check our structure and that it was one structure that turned into two. And from this, we know that there's going to be a condensation, which means a loss of the H2O molecule. So the first thing that we think of is in the question. The intramolecular aldol condensation was carried out as shown. So aldol, what is that? An aldol reaction is where an enol or enolate undergoes an addition reaction with the carbon of the carbonyl group from aldehyde or ketone. So there's going to be a carbonyl group, and there's going to be an addition reaction with another aldehyde or ketone. So then there we're going to translate it. Intramolecular. It's inside the molecule itself, so we know it's one molecule. Aldol, what I just said. And then condensation. The water molecule is going to be lost from the molecule. So here is the general formula for an aldol reaction. Now note that this is with a ketone and not an aldehyde. With an aldehyde, the R4 would be replaced with a hydrogen. So there we go. And then here's the essential condensation reaction that we have. So we're going to have basically the oxygen on the carbonyl group and the hydrogens break off to become water, and it's going to leave a double bond there. So what we know from there is that our starting molecule had to have an oxygen that was double bonded to the molecule adjacent to an area that had two hydrogens, and then leaves a double bond. And that area that it was adjacent to also had to have another ketone or aldehyde. So what we know is it has to be this double bond because it's next to this ketone or aldehyde. It's a double bond, and if you eliminate that, that would be two hydrogens there and a carbonyl group there. So here, that leaves us with that, which is the correct answer.